Are we good? All right, so essentially in this unit, you're gonna have X's on top and bottom, right? Everybody agree with that? Like you're gonna end up with a fraction and you are going to have X's on the top and the bottom. So just know that when you're creating these things. So how do we find the mathematical average? This is 9.1, the word problem. So how do we find the mathematical average? What do you guys do? I want you to find your average of all your tests in pre-cal. What do you do? And divide by how many they are, right? So just keep that in the back of your mind while we do this. So a mobile phone service provides several different prepaid plans. One of the plans has a $10 monthly fee and a rate of 10 cents per text message. So let's talk about that as a linear equation. This is what you would have done in grade 10 to figure out the cost of your cell phone bill.
Like max and
Nope, grade 10. Straight lines. Y equals mx plus b. Okay, so here we go. This plan has a $10 monthly fee and a rate of $10 per text message. Let's create a linear equation for that. How much is my bill going to be a month? Create an equation for how much that's going to cost me. How much am I going to get charged whether I send a text message or not? $10. So my B is 10. That's your y-intercept. My m is 0.1. So my slope is 10 cents per text. Let's call it x, because my t's will look like plus signs and it will be. So do you guys agree that that would give me the cost of what I would pay for a bill on that particular texting plan? Okay, so this is grade 10. Another plan has a monthly fee of $5, but it's 15 cents per text. So what's that one going to be?
why are you putting the B first?
Just because it came, does it matter?
No,
It doesn't matter. I'm challenging you to flip your equation around. It's just the 5 came first in the sentence, so I put it first. But we know that the 15 cents is per text, so that's the thing that needs to get multiplied by an amount. Okay? All right. Okay. Are we ready? So I needed you to get that done, but then I want you to talk about the mathematical average again. So if you were taking your average of all your pre-cal tests, how would you calculate it? And divide it by how many tests you did, right?
It says represent the average cost of each plan, so wouldn't we still do?
So the average cost. So this would be just cost, right? This would be your cost of your plan, and this would be the cost of this plan. So plan 1, plan 2. But we're looking for the average cost.
It says average of each plan, so what does that mean?
That's what I'm trying to get to. I'm trying to get there. Okay, so represent the average cost per text or minute of each plan with a rational function. Right away, right there, that should twig you to you're going to have a fraction. Okay? So, you know the cost. How do I figure out the average cost? What are you going to divide that by? 2. Why 2? Okay, so, but I need to look at per plan. So plan 1, how do I calculate the average cost per text? I'm going to divide the cost by how many messages came in. If your bill is $100, you're going to divide it by the number of texts you sent to get your cost per text, right? Yes, you guys would agree with me? If I say your bill is $100 and you sent 50 texts, how much did it cost you to send every text? $2. Those are expensive texts. So we're going to take the cost of plan 1, so $10 plus our rate per text, and we're going to divide that by the number of texts we have sent. So that's for plan 1. What about plan 2? Same thing.
Not graph the function. There's no line.
Okay. Oh my
Oh, I'm
goodness.
sorry,
Okay, you know what we're gonna do? We're gonna use technology to graph.
Great.
Okay? Can I use Desmos? No, you will not have to. This is gonna be a wonky graph. All right, so we're going to put in our first equation of the average cost. So I need some brackets here. Okay, so let's talk about context for a minute. What does X represent? The number of text messages that we send. So, okay guys, so when we're looking at this, so X is going to be the number of texts that we send. Are we going to send negative text? No. So are we going to have a negative cost? No. So really where we're functioning is on this side of that rational function, just because of the context of this particular question. There is another side mathematically, but in the context of this question, I'm just looking at this side. So now we're going to graph our second function. All right, so do you guys see those two lines? First one's, the red one's the $10 one, the blue one's the $5 one. So those would be, so when I would go ahead and graph that, I'm going to zoom out for a second. Ooh. That's, so at this point, oh, sorry, I'm going to make everybody nauseous. So at this point, let's zoom out again. Okay, so when we start the graph, when we start here at 0 text, which one, we're just jumping right to see which plan is the better option. And so at first it's the blue one, right? Because why? Why, Nicole? Why is it the blue one?
It has a lower Y value.
It has a lower Y value, and what does Y represent? Cost. So we want the blue one at that point. But there comes a time, ladies and gentlemen. There comes a time, and this is really hard to see because they're almost on. Pardon?
We're not going to have technology on the test.
So I wouldn't ask you to do this question.
Then why are we doing it now?
It's a good question.
I don't know how to answer that without getting upset. That's the troubling part of it, is that there's things that sometimes we need to see. Ooh, and it's way over here at, sorry. Oh, I saw my red line there for a second. So all of a sudden here, what's happening? Do you guys see that? The red line is underneath now. So at some point, what happens? They switch. So what point would I be looking for? I'd be looking for that point of intersection, because that would be the time that the bills would be the exact same value. But at that point, when we start, the bills would shift. Now you guys know how much you use your phone.
So wait, why did they switch? Because the red one gets more expensive after? Or because it's cheaper?
The red one after a certain amount of text. So if we look down here, we know that at least at 103 texts, we know that the red is going to be less expensive, right? So there's a couple of things that are important to take from this, is that if you have a word problem, sometimes we reject parts of the rational curve. Another thing you're going to take from this is answering this question is there might not be just one answer. Because at first, the blue graph, the blue equation is less expensive, but over time, the more text message you send, the red one. So not always, you have to look a little bit deeper at the answers. Okay, so that's done. Let's move on to 9.2. right, point of discontinuity. Is everybody on page 13? Yeah, perfect. Okay. So a point of discontinuity is described by an ordered pair where the graph has essentially a point of discontinuity is a hole in the graph. So an asymptote is like a boundary. You can't touch it, you can't cross it. It's like a no-go zone for that whole area. But a point of discontinuity is a specific coordinate pair. So coordinate pair at which the function is undefined. So essentially you have like this hole, this spot in the graph that doesn't work. Okay, so it happens when we simplify and cancel out. So you get a point of discontinuity when you've canceled out something from an x from the numerator and the denominator. And we'll go through it. It will make sense when we do it. Results in a single missing point on the graph. It's sometimes referred to as a hole. Okay, I call them PODs for point of discontinuity. Oh, I just wrote on that. Okay. Let me see if I can undo that and get rid of that black mark. There we go. All right, so is this in transformation form? No. Okay, so the rules of page 1 apply here. So step 1, factor everything. Okay, step 1, we're going to factor everything. And when I say everything, I mean numerator and denominator. So oops, forgot my equal sign. All right, so looking at this, let's do our non-permissible values. Let's do step 2, non-permissible values. So this is kind of like chapter 6 from grade 11. Step 1, factor everything. Step 2, non-permissible values. What are my non-permissible values for this? X cannot equal 3. Beautiful. All right. We are going to simplify the rational equation here. Sure. What am I waiting? So the next step of this is if you can reduce it or you can simplify it, please go ahead. All right, so it has to be the same factor from the top and the bottom, okay? Everybody get that? Like things that you have to multiply? So now that you've canceled it out, what you've created by the fact that you canceled, that is going to be a point of discontinuity. If it stayed there on the bottom, it would have been an asymptote, but it's gone now, it's simplified. So you're left with f of x equals x minus 2. That's pretty exciting. But because you did the act of canceling something out, you have a point of discontinuity, and we know that because we had a non-permissible value. So at what point we have to figure out where our point of discontinuity is. So where's the x value that we can't have? 3. Good job, everybody. So we know that the x coordinate is 3. We know that from our non-permissible value. And to find the y coordinate of it, guess what we do? Substitute it into where? The simplified version. You can't substitute it into here because then you'll get a 0 on the denominator and that's bad. So we're going to substitute the 3 in here. So f of x equals 3 minus 2. What does that give us? 1. So my point of discontinuity is at 1. What kind of graph is this now? It's linear. This one was really ugly to graph. Now what are we graphing? We're graphing a straight line. Life's good. So everything is good for my linear, except we're going to have a hole in the graph represented by an open circle when we graph it at 3, 1. Okay? So, you cannot see,
It's really glary from the window.
somebody can close the blinds.
Oh, Cameron's not here, I was gonna yell at her, but.
You could, but I don't think she's coming back from Winnipeg for us. All right. Okay, what do we know? Start at -2. And our slope is 1. So we're going to go up 1. Do we have an asymptote? We don't, because we got rid of the denominator, right? But by getting rid of that denominator, that removed the asymptote, but it left us with that point of discontinuity. Okay, so my point of discontinuity is at 3, 1. So instead of putting a dot like I normally do like that, I'm going to put an open circle. And I'm going to make it significant just so I don't miss it. Yep, because it can continue on past that point. So then I'm going to connect my dots. I am not going to go through the circle, because that is the hole in the graph.
Sorry, I waited for so long.
So that's the point of discontinuity. Let's talk about our domain for this one. You're going to have to do, because there's a break in the graph, right? Because you cannot have. And what about your range as well? There's a break in your range. So our domain for this graph is going to go from -infinity to 3. Does it include 3? No, because it's a point of discontinuity. So round brackets in unison with round bracket around 3 to positive infinity. What about range? Not inclusive. To positive infinity. Good. Done. Okay. Okay, what's step 1? Step 1 is factor everything. Okay, what's step 2? NPVs. So that should be x cannot equal 1. Okay, step 3, simplify. So we've eliminated that, so we don't have an asymptote, but what do we have? A POD. Now I want to inform you that you can have asymptotes and PODs on the same graph. Yes, and you only canceled out one. The one that was left would be your asymptote. The one that you canceled out is your POD. So my POD is, what's my x value? 1. What's my y value? Okay. Now we graph. Isn't this lovely? So nice, especially when it's all linear. That is foreshadowing. Good call. Good catch on that. You guys know it's never just that easy. Oh, no. Would you like to put your POD on first? Doesn't matter to me, because I always do it first just because I end up forgetting as I'm going ahead and graphing. So y-intercept at 3, up 1 over 1, up 1 over 1. I'm going to go down. All right. Let's do the domain and range just for funsies. Domain. Negative infinity 2, 1 not inclusive, in unison with 1 not inclusive to positive infinity. Range, negative infinity to 4 not including, 4 to infinity. I think we're okay. All right. I don't want to compare the graphs. I want you to talk about key points on the graphs. There's some things I can do here. Oh, sorry. Okay, can I move? We good? All right, so let's talk about f of x for a second. What's the first thing I'm going to do with f of x? I'm going to common factor. I think switching this denominator would be helpful too. I'm going to just switch that around before I factor anything, because I think that will make more sense to you. We totally can. When I cancel these out, what do you know automatically it's going to leave? So we're going to have a point of discontinuity at positive 2 and negative 1. All right, do I have an asymptote? No, I do not. Because really what this is saying is negative 1/2 x. And that's a linear equation, right? That's a linear equation. So there is no variable on the bottom, so we wouldn't have an asymptote. Okay, all right. So we have a point of discontinuity here. We have a linear equation with a negative slope, so it's falling to the right. We're all good. Now let's look at the next one. So for the g of x function, again, before I factor it, I'm just going to flip that bottom around so my x is in the front again. All right. Oh, that's really light. Sorry. Can I cancel anything out here? No, I can't. So do I have a point of discontinuity or do I have an asymptote? So we have an asymptote x equals 2, right? Because we didn't cancel out the bottom this time. Is this going to be a linear equation? No. So this is going to be, what do we know about the vertical asymptote? Might be easier to see it looking at this one, like at that original one. Oh, vertical asymptote is x equals negative 2. What do we know about the horizontal asymptote? These are your rules.
There is none.
They're not the same. This has a degree of 2. This one has a degree of 1. So, yeah, you gotta go back to the original.
So if the top's bigger.
If the top is a higher degree than the denominator,
There's no horizontal.
there's no horizontal asymptote. Is there any point of discontinuity? No, because we didn't cancel anything out. The only time there's point of discontinuity is if we cancel it out. So those would be the differences that I would want you to, like this one is a straight line with a hole in it. This is going to be the graph with the two parts to it with a vertical asymptote at x equals 2. Right? So very, very different graphs. And the only thing that changed between them was one was an add sign and one was a subtract sign. Okay. We're going to match. Super exciting. So what's the easiest thing to do right away? So this one, how many asymptotes does it have? 2 vertical asymptotes. This one has an asymptote and a point of discontinuity, and this one has no vertical asymptotes.
Is there a consequence? No.
Okay, so let's walk through it. I think the easiest way to do it is to take your equations and factor everything.
Whoa. That one has 2 vertical.
So if I'm looking at that first one and I factored it, what happens? So this cancel each other out, leaving POD
That's -2.
at x equals -2. And I mean, we could find the y value, but really right now, those aren't key points. Like, we can do the work, but we don't have to do the work. So this graph is it still has a denominator, so that's going to be a vertical asymptote. A vertical asymptote at x equals +2. So those are some key points. Do we have that graph?
Number 2.
It's graph number 2. So this belongs to function ax. Okay. All right, so if we look at the second one here and we factor it, this is 2x plus 2. Can I factor the denominator? No. I can't. Because it's not a difference of squares, it doesn't have the subtract in between them.
You can't really make it equal to 0 either, so
Oh, wait, difference is squares.
the denominator.
Pardon? Sorry?
You can't really make the denominator equal to 0 either. So
Right.
It's just number 3.
Yeah.
Right.
Okay. What do we know would be the y-intercept? So this one's a little bit different, because would we have a horizontal asymptote? Would we?
0. It's
Oh,
zero.
wait, it's less than the
square.
bottom.
The numerator is greater than both.
Oh my goodness, guys. So you're looking,
So less
guys,
than
It is 0. I was trying to time. Why did you
I
say
know,
that?
but you're not confident in it. You don't know why it's 0.
I know why it's 0.
Oh,
I was
good.
thinking.
Okay. You were waffling.
I
Okay.
know what that word means.
You weren't confident in your answer. What's your y-intercept here? 4. So we're looking for a y-intercept of 4. So what's x when we're looking for a y-intercept? Right, so we just substituted that in. Do we have any vertical asymptotes? Do we have any vertical asymptotes?
No.
No, we do not. So what graph doesn't have vertical asymptotes on it? I know it goes a little bit below,
Yeah.
but I think that's a mistake in the graph.
Okay.
Sorry.
So we don't have to solve the other one.
So, but let's do it just for funsies.
Um,
Look, you guys will be fine.
Okay.
So this one's going to be 2x over x plus 2, x minus 2. Anything I can cancel out?
No.
No. So no point of discontinuity. I'm going to have asymptotes at x plus 2 and x minus 2. Yeah?
For the other one, like BX, I
It did, and I just explained that to Basil. I think it's just like the graph just went down a little too low when I was graphing it. It shouldn't be there, sorry.
I was gonna say,
So this one has two asymptotes, nothing cancels each other out. We don't have a point of discontinuity, so it's going to be this graph. Everybody good with that? Okay, so this one is C of X. So we only needed like key points to help us figure out which one matches what. And although that answers this question, I'm hoping though that you can identify these same things when I ask you to graph something right from scratch. Like you should know looking at this that I'm going to have two asymptotes. This one I'm going to have one asymptote and a point of discontinuity. Because if you can do it here, you should be able to do it on the ones that you know. Okay, go. Go. Just do it. Just do it. Yeah. Sure. You guys good? I'm going to tell you the only thing I looked at were vertical asymptotes. Are we good? Are we good? Yeah? All right. Yep. Oh, I didn't do any work. Okay. So all I did, like I said, the only thing I did for this question was look at vertical asymptotes. So all I was looking at was denominators. So this is going to be x minus 2, x plus 1. I know I can't factor my numerator. So how many asymptotes is this one going to have? 2. So that's the far graph. factor this one. X minus 1, X plus 1. Those cancel each other out. That's just the bottom. So I'm going to have a 1 on top, and I'm going to have X plus 1 right there. So I know that this one should have a whole, because I canceled stuff out, and an asymptote. So one asymptote at -1 and a whole at +1. So that one is LX. And then this one is nice, factor the top. It's going to be X minus 2, X minus 3. The denominator, I'm going to common factor out a -1. So I'm going to have X minus 3. So those end up canceling each other out. No denominator. So I know I've got a whole at +3. So that's that.
Good job, Shannon.
Point of discontinuity done in the bag.